Data table is a package that is downloadable within the RGui or the RStudio, whichever you use. And what it does is it offers a new data structure called data table, which is essentially a data frame with a sort of add-on functionality. And it's faster and more memory efficient, which proves very useful when working with big data. And it also includes functions that are available within the brackets, so to say, while the data frame only allows you to subscript using the brackets. You can also get actual functions executed by providing them within the brackets for a data table. And it's quite similar to SQL. I don't know SQL myself, but apparently it's very similar in its structure. The downside is that you have to use a completely different syntax for the data table, or at least you have to do that in order to get the full functionality and the increased speed that is the main virtue of the data table package. So it actually requires that you learn a new syntax, but still is great for large data sets where time can be a factor that is really of importance. In this presentation I thought I'd give you a brief overview of the package, and I'll kind of focus on where it differs, the syntax differs from that of the usual data frame, which you're probably very familiar with. So it's not a complete presentation of everything you can do in a data table, but it focuses on the things that can cause troubles, I would say. In a data frame, the general syntax within the brackets is I, j, where I is the row selection, where you select rows or you state some sort of expression or conditions that need to be met in order for the rows to be included in the selection. And j after the comma is where you choose the columns that you want included in the data frame that you sort of extract when subscripting. In data table you have three things with two commas. So you have I, j, and by. And I is very similar to the data frame with the row selection. And j lets you select the columns, but it's also a place where you can put actual functions. So instead of wrapping, as for a data frame, the data with the function that generates something, a mean value or aggregation or something, you can put it inside the brackets of the data table itself, and while subscripting also get the results from this function. And finally, by lets you group the data in order to perform some sort of function by a grouping variable or several grouping variables. So let's start with the easy part, to read data from a file into the RAM memory. And throughout the presentation I'll demonstrate how you do it the usual way in a data frame, and then how it's preferably done using data table in order to get this extra speed that is generally the main advantage of data table. So if we have a CSV file, a comma separated value file, we can read that into memory using the read.csv function and put it in an object called df here, which stands for data frame. And if we look at the structure of what we read by writing a structure or str, we get this. So what this file contains is the raw data from a census in New Zealand with one row per individual, and it's actually 3 censuses from 3 different years, so you have approximately 15 million rows in this dataset. It's kind of large, not huge, but it's a large dataset. And we have 6 variables. The first one here is just a number, like an ID. And then we have the year the census was performed, we have the age of the individual, the sex, the ethnicity, and the area where this individual happened to live as the census was performed. To read the same data as a data table, we use the fread function. And to get access of that, you obviously have to install the data table package and load it into memory using the library function. But once you've done that, you have this function fread. And if we do that and put it in something called the DT for data table and look at the structure, it looks very similar. We have the same number of observations and the same number of variables. But you might notice that sex, ethnicity, and area here turn into factors, which is often the case when loading a data frame using the read.csv function. While when using the fread function, nothing is ever turned into a factor, but it remains a character moved vector. So that's a difference. Another important difference is that fread is much faster. In this case, it turned out to be 10 times faster than the read.csv function. Exactly how many times faster it is probably differs depending on what kind of data you have, but I present the numbers for this specific data set, and now it turned out to be 10 times faster, which could be great. If it takes like 10 minutes to load the data, then 1 minute is better. If we want to look at the data set, we can just write the name of the object. This is the data frame, and since this is a large data set, you get quite a lot of data here, and then as you often see, you have data omitted. You have some sort of maximum number of rows that will be presented, and then it omits more than 15 million rows in this case. But still, you have quite a lot of rows here, and I've actually cut away quite a few in the middle here. When you write DT for the data table, you get this instead. And if you have a large data set, you always get the first 5 and the last 5 rows of the data set. And that's kind of convenient. It doesn't fill the console with a lot of data that you're probably not that interested in anyway. So you get a general idea of what the data set looks like. If you want to, for example, select the first 3 rows of the data set, when using a data frame, you simply write data frame brackets 1:3, which gives you a vector with numbers 1, 2, 3, and then comma, and then nothing in particular here because you want all the columns. And in return you get the data frame with all the columns and the first 3 rows. You can do the same thing for a data table, but you can also omit the comma here. You don't need that. You would need it for a data frame, and at least I tend to forget it quite often, and that's a problem. But here you can forget it on purpose if you want to, because it doesn't matter. You still get the first 3 rows from a data table. If you want to select only the rows with males from Canterbury, you would write df, the object data frame, df $6 equals male for the males, and you also have a condition that df $area is Canterbury, and then you have the comma and all columns. And that would give you a data frame containing all the rows where the sex is male and the area is Canterbury. If you want to do this on a data table, you can write dt sex equals male and area equals Canterbury. And as you notice, or might notice, there's no dt $ here, and that is because columns are automatically referred to as variables in a data table. So this part sex here is not interpreted as an object as it would have been if this was a data frame, but it's interpreted as the name of a column. So what R does is it goes into the sex column and looks for males, and it goes into the area column and looks for Canterbury. The good thing is that this selection turns out to be 10 times faster than its counterpart for data frames. So it's really much faster. You can write it the ordinary way as well. Doesn't matter. If you want to, you can use this syntax, but you don't have to. If you want to order the data set by age and sex, for a data frame you would write the name of the data frame, df, and then within brackets you use the order function, and then what you're supposed to order it upon, df $age and df $sex, and then you will get the entire data frame ordered accordingly. In a data table you do basically the same. You use the order function, but you can skip the dt here, dollar, and just write age and sex. They are automatically interpreted as column names. But order is internally optimized when used upon a data table. So it turns out that this ordering is 4 times faster for the data table compared to the data frame. And if you want to, of course, you can write dt dollar here as well. Doesn't matter. This is where it begins to get a bit tricky. When you want to select columns, the dollar version is quite simple. It's the same as for data frame. If you write df for data frame $6, you get the sex column as a factor, because that column happens to be a factor because it was converted into a factor when read using read.csv. If you do the same thing for the data table, dt $6, you get the sex column as a vector because that's a character mode vector, because of the fread that doesn't convert things into factors. You can also, as you probably remember, use the brackets and write df, all rows, comma, and then the name of the column within quotation marks, and then you get this column as a factor once again. If you do the same thing for the data table, though, you actually get the correct column, but you don't get it as a vector anymore. You get it as a new data table with only one column, the column 6. And if you want to use the bracket version and actually get the vector, you would have to write dt nothing, comma, 6 without the quotation marks. Then it's interpreted as the column name and it's returned as a vector. So if you want to select more than one column, for example the columns sex and age, you obviously can use the bracket version, df bracket all rows, comma, and then a vector using c concatenate or combine to get a vector, and then you write sex and age within quotation marks to get a character mode vector with 2 elements, each one corresponding to a column, and what you get in return is a data frame with these 2 columns. If you do the same thing for the data table, it works just fine, and you get the data table. And here it's okay to write the quotation marks. But if we try to do as in the previous example and skip these quotation marks and just wrote dt bracket all rows c sex age, then we would kind of unexpectedly perhaps get a vector, and a very long vector, actually twice as long as the number of rows in the data set, something like 30 million elements. And what it's done is that R has taken the sex column and then combined it using the C function with the age column. So you have a very long vector, and the first half of this vector is all the values from the sex column, and the second half is the values from the age column. And that's an example of where you're actually using a function here. In this case, it's the function C to do something upon these columns, which is sort of unexpected because you wanted to select them. So what you would have to do if you want to write it this way without the quotation marks is to put a dot or a point in front of the parentheses here instead of a C. And this point is actually a short form of list, so you could write list instead. And once you turn this into a list, then it's interpreted correctly by the data table, and what you get in return is a data table with these two columns. And then something that can be problematic when you have the column IDs stored in an object and you want to use that object to point to the columns that you're interested in within your data table. So I'll demonstrate what I mean here. For a data frame first, we store the name of a column, sex, in a new object called CName, and then we ask for df, the data frame, all rows and column CName. And as you remember, CName here is interpreted as an object. R looks for an object, finds the object, and extracts the contents of it, which is sex. It goes into the data frame, looks for a column called sex, finds it, and returns the contents of that column as a factor, because it is a factor. You can also use a number. The sex column is column number 4, so we store this in CNum equals 4. Then we ask for df, all rows, column CNum, and we get the 4th column as a factor. But if we do that on a data table, we just get an error. It doesn't work. So what we have to do, which is not entirely obvious, is that you have to put 2 points in front of these names, CName and CNum. So if you write dt all rows, comma, point, CName, then you get the data table with the sex column only. And if you do the same thing for the CNum, you get a data table with the sex column as well. And why do we use 2 points here? Well, that's because point in this case means 1 level up. And by that I mean look for the CName or the CNum among the objects in the workspace, not among the columns in DT. What R does as default is to look among the column names for a match. But if you insert this point, we say don't look there. Go 1 step up, and up in this case is out of the data table into the workspace, and look for an object in the workspace. And it actually finds an object called CName or CNum, and within that is the information that gives you the right column. And the use of double points this way is inherited from Unix and from DOS as well, operating system that preceded Windows. And in those environments, the double points means parent directory. So it's the directory 1 step further up in the hierarchy in the directory tree, so to say. Finally, I'll show 2 examples of how to use functions within the brackets in order to get some sort of aggregation or calculations out of the data table. If we, for example, want to make a table of the area and year to know how many individuals were in each area each year, for a common data frame we would write table probably, and choose the first column, comma, the second column. And what we get in return is a matrix with 1 column per year and 1 row per area, and then we have the number of observations for each combination of year and area. When using a data table, we would instead write dt all rows and then point, and within parentheses point n. And this point n is a special function that counts the number of rows. And then another comma and by. And by indicates a grouping variable. And then the point here for list, and within the parentheses only the names of the columns that contains the grouping variables area and year. And what we get in return, it doesn't look exactly the same. It's more like an aggregated thing here. So we have Northland for 2018, Northland for 2013, and Northland for 2006, and so on. But the good thing is that this version turns out to be 12 times faster than this one. And you may also notice that these areas are in alphabetical order, and they are not here. They're in the order of appearance, so to say. So the first occurrence of an area was Northland, so that ends up on the top. And that's true for most things in data tables. You don't have the alphabetical order of the output. You can write a table as well and get the same output as here, but then you don't save any time, so it's not quite as good. If instead you want to calculate the mean age of men per area and year, for a data frame you would possibly use aggregate. So you can write aggregate age as a function of year and area, and the data is in df, and the function is mean, and we would like a subset, so we only get the males. And the output is all kinds of combinations between years and areas, and for each of these combinations we get the mean age of the men. If you want to do this on a data table and get it done quickly, then you would have to write dt, and first the selection of rows, here the subset sex equals male, comma, and then what we want to do, a point for list, and then the function mean, and then within parentheses age. And age, of course, refers to a column. So you want the mean of the age column, and you want this done grouped by area and year. And you use the dot or point here as well for list. And what you get in return is Northland 2018, Northland 2013, and so on. And it turns out to be 10 times faster than the aggregate version. So to summarize, well, first I need to say that this was not all you can do in data tables. Obviously, you have a lot of functions that I haven't mentioned, and you have something called keys. You will have to look that up if you want to do everything you might want to do using data tables. And it takes quite some time to get used to the syntax, and those that are familiar with SQL apparently think it's a better syntax than the one for data frames, or at least some people think. But to me it's quite difficult, and well, it takes some time to write the code that does the things you want in a fast and efficient way. But if you're working with large data sets, the analysis could take a day or several days sometimes, and then it's a great advantage if you can compress this to perhaps 1/10 of the time. So it's definitely worthwhile to learn how to use data tables, or at least look up when you want to use them, how to do the things you need to do if you're working with a large data set.